Hello students, welcome back to Engineers Academy. Do hit the subscribe button if you haven't done it yet. Now we are going to solve this problem from chapter 8, friction. And the problem says that a worker walks up the slope roof that is defined by the curve y equals to 5 into e to the power 0.0 x feet, where x is in feet. Determine how high h can go without slipping. So we have to find this h from the ground, or we can say that from the x-axis, and the coefficient of static friction is mu s. So now, as we know that while as the worker moves up, he is applying the force on the roof in the downward direction. So the roof is going to apply the friction force on his feet in the opposite direction, so that is in the upward direction. So let's say that we are having the friction force in this direction, and that friction force is, let's say, F. And now the roof is going to apply the normal force on his feet in the upward direction. So let's say this is NB, let's say this is N. This is the normal force, and his weight is going to act in the downward direction. So this is his weight. So now this is the weight. Now if I extend the line of action of this weight, and let's say that at this particular location, when the worker is here, let's say, so here this roof is making some angle theta, let's say. So let's say we have some angle theta. So let me mention that angle theta. Now as we can see that this n is perpendicular with this line, and this vertical line is perpendicular with this line. So if the angle between this line and this line is theta, then the angle between this and this line is also theta. So here we have that angle theta. And now if I extend the line of action of this normal force like this, so this weight is going to make that same angle theta. If this is angle theta, this is angle theta. So we can say that this is also angle theta. Now let's assume that in the upward direction, parallel to the roof, we have our positive x-axis, and perpendicular to the roof, that is our positive y direction. Now, since we want to find how high he can go without slipping, if he is not slipping, he is moving with, we can assume that he is moving with constant velocity. If he is moving consistently, and if he is not slipping, we can say that he is in equilibrium. So if he is in equilibrium, the summation of forces along x and the summation of forces along y, that must be equals to 0. So now if I apply the summation of forces along x is equal to 0, so then we need to resolve this weight. So this weight will have two components. It will have one component in this direction, and it will have one component in this direction. So let me show that component. This is the sine component, and here we will have the cos component. This component is the w cos of theta, and this one is w sine of theta. And now if we apply the summation of forces along x, so as we can see that this F force, this is acting in the positive x direction. And if the system is in equilibrium, and if he is not slipping, so the roof is going to provide the maximum friction, and that maximum friction will be equal to mu s times n. So mu s is 0.6 times n, the normal force. So the normal force is n. So now this f, the small f, 0.6 n, is acting in the positive x, so I will write 0.6 n. And this weight component is acting in the negative direction, negative x. So you will write minus w sine of theta, and this is equal to 0. And from this we can say that minus w sine of theta is equal to minus 0.6 n. Minus will cancel out. So we will have w sine of theta equals to 0.6 n. Let's say this is equation 1. Now if we apply the summation of forces along y, that must be equals to 0. And this is our positive y direction, this is our positive x. So now as we can see that this weight, the cos component of the weight, is acting in the downward direction, that is in the negative y. So I will write minus w cos of theta, and the normal force is acting in the upward direction. So that is plus n, and this is equal to 0. So now from this we can say that minus w cos of theta is equal to minus n. Minus will cancel out, so we can say that w cos of theta is equal to n. So this is our equation 2. Now if I divide equation 1 by 2, so we will have w sine of theta equals to 0.6 n. So dividing equation 1 by equation 2, so we will have divided by w cos of theta divided by n. So this is w sine of theta is equal to 0.6 n divided by this equation 2, w cos of theta divided by n. So w will cancel out and n will cancel out. So here this will cancel out and this will cancel out, and sine of theta divided by cos of theta is tan theta. So we can say that tan theta is 0.6. Now at this particular location, when the worker is somewhere here, the profile of the roof is defined by this y of x function, and if this is the y of x function, the tangent to this path at any point will be the derivative of this y of x function. So if you want to find the tangent to the roof at this particular point, so that will be dy by dx, and that dy by dx will be equal to tan theta, since we know that if I draw a tangent to this particular point, and if I draw a horizontal line here, and if I draw a vertical line, so this is the change in x. This is the change in x. So let me write that this is that this will be the change in x dx, and this will be the change in y. And let's say if this is that theta, since we have considered that at this particular instant the roof is making some angle theta, so this is that same angle theta. So now we can say that if I apply tan theta to this triangle, so we can say that tan theta is equal to dy by dx. So tan theta is perpendicular divided by base, which is dy by dx. So now if I find the derivative of this equation, so that derivative of that y of x function will be equal to 0.6, since tan theta is 0.6. So we can say that dy by dx is equal to 0.6. Now the derivative of that y of x function is, we can write that y is equal to 5 into e to the power 0.01x. Now the derivative of this is dy by dx. This is equal to 5 and 0.01, the derivative of this power, and then the derivative of this. So the derivative of this will be again e to the power 0.01x, and now we know that dy by dx is equal to 0.6, so this is equal to 0.6. So now we can write that this is equal to 0.6. So now we can say that e to the power 0.01x is equal to 0.6 divided by 5 into 0.01. So 0.6 divided by 5 into 0.01, this gives us 12. So e to the power 0.01x is equal to 12. Now in this equation we want to find this x, and this x will be the position of this worker from the origin in the x direction. So this will be somewhere, he will be at x. So now let me show that x position. This will be, now let's say at this particular instant from the origin he is at a distance of x, and from this particular point from the origin the position of the worker in the y direction is defined by this. So at any instant this height is represented by y, and that y is equal to 5 e to the power 0.01x. So if we find the position of the worker in the horizontal direction, we will substitute that x value in this equation, and that will give us the y value, which will be the height of the main from the ground, which is required. So now this will give us the x value. So to find this we have to take the natural log on both sides of the equation. So this is e to the power 0.01x and natural log of 12. So applying natural log, we can't move this power here, so that will become 0.01x natural log of e This is equal to natural log of 12. Natural log of E is 1. So we can have 0.01x equals to natural log of 12. And from this we can say that x is equal to natural log of 12 divided by 0.01. So natural log of 12. So this is natural log of 12 divided by 0.01. This gives us 248. So x is equal to 248.49 feet, since x is in feet. So at this particular instant, when tan theta is 0.6, he is at a distance of 248.49 in the horizontal direction from the origin. So this distance is 248.49 feet. So we can write that this is. Now we want to find his height. So now we have the y as a function of x. So we need to put this x value and that y as a function of x. So y is equal to, we can say that y is equal to 5 e to the power 0.01 into x, which is 248.49. So 5 e to the power 0.01 into 248.49. This gives us 59.999, which is approximately 60 feet. And this is the y value, or we can say that this is y equal to 60 feet is equal to the height of the man at that particular point where tan theta is equal to 0.6. And we got this tan theta using the equilibrium conditions. So now the answer is that he is at a height of 60 feet. So he can move a distance of 60 feet in the y direction without slipping. So this is the solution of this particular problem. I hope it will help you in your learning. Let me know in the comments if it helps in your learning. Do subscribe Engineers Academy and share it with your friends if it helps in your learning.